So good morning. Today's class we are going to deal with ladder friction. So a ladder, as seen in the figure, see, a ladder is kept one end on the floor and the other end it is leaning against a wall. So as far as this say, suppose this ladder, if it is a sort of inclination like this, it will be stable. As we go on increasing it, the slope with the ground is increased. This is angle. If you go on increasing the slope, what will happen? The ladder will slip. Okay. Similarly, due to its self-weight or when a man climbs on it, this has a tendency to slip. Once it slips, what will happen? The upper end, the end which is in touch with the wall, it will come down, and the end which is in touch with the ground, it will move towards right. So if you know these two facts, we can easily solve any example of ladder friction. So a ladder, so this angle theta, there is some limiting angle, you may have to find out that one. Here a ladder, some person will be climbing over it, so you will be given the weight of the ladder, weight of the person climbing on it, then you will be asked to find out what is the limiting angle so that it is in limiting equilibrium. So at the limiting equilibrium means it is at the verge of impending or at the verge of slipping. So just remember, once it slips, if it is like this end moves towards right, the lower end, and this upper end comes down. So now we can have to draw the free body diagram. Once we draw the free body diagram, what we do? We free the ladder from all the supports. I am drawing the supports just to show this vertical and horizontal line. I am marking this ladder. So what are the forces? The self-weight. The self-weight of the ladder will act at its center of gravity. At its center. If its total length is L, then this will be L by 2. This length will be L by 2. So the self-weight will be acting at the midpoint of the ladder. Then there is contact between this ladder and the wall. So there will be a contact pressure or contact reaction acting normal to the surface. Normal to the wall, there will be a contact reaction. Similarly, there will be a normal reaction between the floor and the ladder perpendicular to this horizontal surface. This is perpendicular to the vertical wall. So there will be normal reaction acting from here and normal reaction acting from here. I will mark it as A. If this point is designated as A, I will mark it as reaction at A. If this point is designated as B, this is RB. So there will be normal reaction at the contact surfaces perpendicular to the contact surface. Then friction. If the wall as well as the floor are rough, there will be frictional force. If it is smooth, there will not be any friction. If it is rough, assume that the wall is rough, so there will be frictional force. This direction of motion is downward. This end is moving down, so the friction will be acting up. So the frictional force acting at this point FB will be equal to mu times RB. Mu times RB. Here this end tends to slip towards right, so there will be frictional force opposite to that. That will be FA. Friction at A will be mu times RA. So this is the free body diagram. Very simple. You mark the ladder, mark the contact surfaces, self-weight acting at its center, and normal reaction at the contact surfaces perpendicular to the surface, and the frictional force. Frictional force here towards right, frictional force towards up. Then we have to make use of the equations. Sigma. Here we have to make use of three equations. Sigma Fx equal to 0, sigma Fy is equal to 0, and sigma M about any point is equal to 0. So in the case of wedge as well as a single body cases, we have to use only sigma Fx 0, sigma Fy 0. But in the case of analysis of ladder friction, we may have to use the three equilibrium equations. Moment about any point, either you can take moment about A and equate it to 0, or take moment of all the forces about B and equate it to 0. Okay, suppose I want to find theta. In this case, suppose we are asked to find out the inclination of the ladder so that it remains stable. In order that, or it is at the point of slipping, it's at the verge of slipping or for limiting equilibrium. How will you find out? Say these are the forces we have marked here. We will write down sigma fx is equal to 0. Sigma fx is equal to 0 means RB acting towards right. Or I'll mark sigma fx is equal to 0 will give you RB minus mu RA is equal to 0. That is one equation. Then sigma Fy is equal to 0. That will be RA acting upwards, mu RB acting upwards, RA plus mu RB is equal. Then one more force, W minus W is equal to 0. Second equation. Then we take moment of all the forces, say about A. I take moment about A, the lowermost point, so that the RB into perpendicular distance. This is the line of action of B. From that line of action, perpendicular distance up to point A. So that is equal to, this is the perpendicular distance. So RB, that will produce clockwise moment with the tip pointing like this. About A, if we turn it, it will rotate it clockwise direction. So RB into distance BC. Then what about this mu RB? Mu RB will also produce, this is mu RB, the perpendicular distance, this is the line of action. So this is the perpendicular distance. That will also produce clockwise moment plus mu RB into, this is the perpendicular distance CA. Then what about W? W will be producing an anti-clockwise moment, and see, if I extend this line and say mark it as A, B, C, I have marked say D. So W into this much distance, this is the perpendicular distance, that will produce anti-clockwise moment. So minus W into dA is equal to 0. Our aim is just BC, CA and DA can be obtained from the trigonometry of the figure. What is BC? You are given the length of the ladder. So BC is the opposite side. This is the hypotenuse. So I can write BC by L or BC by AB. BC by L is equal to sin theta. Opposite side by hypotenuse. So BC is equal to L sin theta. Similarly, CA. CA is the adjacent side. So CA by L is equal to cos theta. Therefore, CA is equal to L cos theta. What about DA? This triangle, consider this. Let it be G. GA is L by 2, half. And this is theta. So DA is equal to, I can write DA by L by 2 is equal to cos theta. Therefore, DA is equal to L by 2 cos theta. So in this equation, I can substitute everything in terms of L sin theta cos theta. L is known to us. So from this equation, we can find out what is the value of theta. That will be one question. If theta is given to you in the question, you may be asked to find out the normal reactions at the contact surfaces. So we can see the numerical examples of both these types. So the general principle in ladder friction is draw the free body diagram, use the three equilibrium equations and solve for the unknowns. So let us see this numerical example. I will read the question. A uniform ladder of length 10 meter and weighing 20 Newton is placed against a smooth vertical wall with its lower end 8 meters from the wall. In this position, the ladder is just to slip. Determine the coefficient of friction between the ladder and the floor, frictional force acting on the ladder at the point of contact between the ladder and the floor. So we can see how to solve this. So in this question, the things given are uniform ladder of length 10 meter. So the length of this ladder is 10 meter. Then its weight is 20 Newton. Weight is 20 Newton. So the weight is 20 Newton. It will act at the center. Weight is 20 Newton. If it is 10 meter, this distance is 5 meter and this distance is 5 meter. Then its lower end is 8 meter from the wall. So this lower end is 8 meter from the wall. We are given the length of the ladder as 10 meter and the lower end is 8 meter from the wall. It is about to slip. The ladder is at the verge of slipping, or it is at limiting equilibrium. Determine the coefficient of friction between the ladder and floor. And this is given, this wall is smooth. This wall is smooth. Smooth means there is no friction. If the wall is smooth, there is no friction between the top edge and this surface. Okay, this is the question. We are asked to find out mu. You are asked to find out what is the coefficient of friction between the ladder and the floor. This is the floor. So as I have mentioned earlier in the previous video, we just draw the free body diagram. So drawing the free body diagram, at the center of the ladder, its self weight will be acting. So the self weight is going to act at the center, W 20 Newton. And this is the flow, and this distance is given as 8 meter. So this is 5 meter, this is 5 meter, the center is G. I will mark this point of contact as A and this point of contact as B. So I have marked the self weight first, then mark other forces. What are the other forces? We have to mark in the free body diagram the normal reaction at the surface. Here it will be RA. Similarly, here the normal reaction RB. It will be perpendicular to the surface. This is also perpendicular to the surface. Since this is smooth, this friction here, friction at B is 0. Since the surface is smooth, this is 0 because it comes down, so friction is upwards. Since the surface is smooth, this is 0. Here, this has a tendency to move towards right, so this is the friction. Fa is equal to mu Ra. So that's all. This is the free body diagram. The free body diagram of ladder is very simple. Mark the self weight, the normal reaction, here the normal reaction, the frictional force, here it is 0, the wall being smooth, since the wall is smooth. This is frictional force opposite to the motion. Ladder slips and it goes towards right, so frictional force is mu Ra. All these we are marked. Now we have to find out this angle theta. What is the inclination? How will you find out? This distance is given 8 meter, this is given as 10 meter. So adjacent side divided by hypotenuse. We can write down cos theta is equal to, I will mark it as AC. AC divided by AB. 8 by 10. Hence distance BC can be found out as root of 10 square minus 8 square. So that is equal to 6. So you can find out this distance because this is also required for us. So this distance we got it as 6 meter and theta 0.8 by 10 we find out the theta. Okay. Next we write down sigma fx is equal to 0. Write down sigma fx is equal to 0. What are the horizontal forces? RB acting towards right. Mu RA minus mu RA is equal to 0. Equation 1. Next, you write sigma Fy is equal to 0. Sigma Fy, this Fb is 0. RA minus W, RA minus 20 is equal to 0. Therefore, you get RA is equal to 20 Newton. Once you get RA, you can get RB from 1. RB is equal to mu RA. Mu is an unknown. So, RB is equal to 20 mu. Because we are asked to find out mu is an unknown. Okay. Next, we take moment of all the forces about A and equate it to 0. That is right. Sigma MA is equal to 0. Moment about all the forces about A and equate it to 0. Moment about A, RB. This is the direction of B. About A, it rotates clockwise. RB into perpendicular distance. That is BC. RB into BC plus there is no force, no friction, so there is will not produce any moment. Then W into produces anti-clockwise moment. Say let it be H. W into what is the perpendicular distance? This is the line of action. So this is the perpendicular distance. Or I will mark it as D. A B C D. Okay. W into DA. Sign is anti-clockwise. So minus W is 20 into dA is equal to 0. Let us substitute the values. What is BC? BC is 6 meter. What about dA? How to find the dA? Look into this triangle, small triangle. If you have found out theta, we can write down dA is equal to 5 cos theta using this. Or this is 5 meter. This is totally 8. This is the midpoint. So dA will be 4 meter because this is a similar triangle. From the principle of similar triangles, this is 10. This is 8. The perpendicular bisector from here will be at 4 meters. So dA is 4 meter. BC is 6 meter. Substitute into this RB. RB is mu RA. RB, we have got here it is 20 mu. So 20 mu into 6 minus 20 into 4 is equal to 0. From that we will get mu is equal to 4 by 6 or 2 by 3. So by taking moment about A equal to 0, substitute for RB. RB is equal to 20 mu into 6 minus 20 into 4 is equal to 0. So we will get mu is equal to 0.67. So the first part is over. Then we are asked to find out the frictional force acting on the ladder at the point of contact. The frictional force at the point of contact between the ladder. So Fa is equal to, the frictional force Fa is equal to mu times Ra. So that is equal to, what is mu? 0.67 into Ra. Ra is 20. That into 20. 0.67 into 20 is okay. If you want to find out Rb also, that can also be easily found out. If you want to find out Rb, the reaction Rb is equal to 20 mu. 20 mu is equal to 20 into 0.67. So we can find out all the unknowns. Ra, Rb, frictional force, everything can be obtained by using the 3 equations of equilibrium. Thank you. The next video we will see another class of example from ladder friction.